Hello dear students, I welcome you to my this video channel. I am Dr. Yusuf Hanif Sheikh, Associate Professor, Department of Physics, Shivaji College, Kannad. Today I am going to teach you Zeeman pattern for D1 and D2 lines of sodium. Anomalous Zeeman effect is seen if the atomic states involved in producing the spectral line have S vector is not equal to 0. In this case, a single spectral line splits up into 4 or more lines. As S vector is not equal to 0, the values of G, Ji and G, Jf are different for initial and final energy states of the atom. For an example, consider the splitting of D1 and D2 lines of sodium. The D1 line of lambda 1 is equal to 5896 angstrom is emitted by 3 square S half dash 3 square P half. That is the transition of the electron and D2 line lambda 2 is equal to 5890 angstrom by transition from 3 square S half to 3 square P 3 by 2 transition of the electron. Since the sodium has atomic number 11, it has 2 electrons in the first orbit, n is equal to 1, 8 electron in the second orbit, n is equal to 2, and 1 electron in the third orbit, that is n is equal to 3. So 3 square S half level, it denotes that n is equal to 3 and L is equal to 0 and J is equal to half, and 2S plus 1 is equal to 2, that is S is equal to half. 3 square P half level, it denotes that n is equal to 3 and L is equal to 1. J is equal to half and S is equal to half. 3 square P 3 by 2 level, it denotes that n is equal to 3, L is equal to 1, J is equal to 3 by 2 and S is equal to half. The frequency of D1 line when no magnetic field is present be represented by μ0. If the line is emitted due to the transition from 3 square S half to 3 square P half, we think that the splitting of these two energy states in the presence of magnetic field, the ground state 3 square S half is split up into 2J plus 1, that is equal to 2 sublevel. For this state, Gji is equal to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J multiplied by J plus 1. That is equal to 1 plus half multiplied by 3 by 2 plus half multiplied by 3 by 2 divided by 2, 1 upon 2 multiplied by 3 upon 2, that is equal to 2. For J is equal to 3 by 2, then J is equal to plus 3 by 2 plus half minus half and minus 3 by 2. So Gj multiplied by Mj is equal to plus minus 1. The state 3 square P half is also split up into the 2J plus 1 is equal to 2 sublevel, and Gg is equal to 1 plus J multiplied by J plus 1 plus S multiplied by S plus 1 minus L multiplied by L plus 1 divided by 2J into J plus 1. That is equal to 1 plus 1 upon 2 multiplied by 3 upon 2 plus 1 upon 2 multiplied by 3 upon 2 minus 1 multiplied by 2. upon 2 multiplied by half, 2 multiplied by 3 by 2. This is equal to 4 upon 3. So j is equal to 3 upon 2, mj is equal to plus minus half, and gj mj is equal to plus minus 1 upon 3. As per transition rules, only those transition states are possible for which delta mj is equal to 0, plus 1 or minus 1, with exception that mj is equal to 0 to mj is equal to 0 is not allowed. For mj is equal to 0, the two transitions are possible, that is from mj is equal to plus minus half for 3 square p half to mj is equal to plus minus half for 3 square s half. Use two different frequencies, that is nu1 and nu2, where nu1 is equal to nu0 plus delta nu inside the bracket plus 1 upon 3 minus plus 1, that is equal to nu0 minus 2 upon 3 delta nu, and nu2 is equal to nu0 plus delta nu minus 1 upon 3 minus 1 bracket complete, that is equal to nu0 plus 2 upon 3 delta nu. For mj, delta mj is equal to 1. Again only one transition is possible, that is from mj is equal to plus half for 3 square p half to mj is equal to minus half for 3 square s half. Use two different frequencies. Now nu3 is equal to nu0 plus delta nu inside the bracket plus 1 upon 3 minus 1 bracket complete, that is equal to nu0 plus 4 upon 3 delta nu. For delta mj is equal to minus 1, again only one transition is possible, that is from mj is equal to minus half for 3 square p half to mj is equal to plus half for 3 square s half. Gives two different frequencies, that is nu3 is equal to delta nu0 plus delta nu inside the bracket minus half minus plus 1 bracket complete, that is equal to nu0 minus 1 upon 3 delta nu. So the D1 line of frequency nu0 is split into 4 lines of frequency, that is nu0 plus 4 upon 3 delta nu, nu0 plus 2 upon 3 delta nu, nu0 minus 2 upon 3 delta nu, nu0 minus 4 upon 3 delta nu, and delta nu is equal to E upon 4 pi m into B. For D2 line, let us consider frequency of D2 line when no magnetic field is present is represented by nu0. If the line is emitted due to transition from 3 square s half to 3 square p 3 by 2, we have seen that the splitting of these two energy states in presence of magnetic field. For the ground state, 3 square s half is split up into 2j plus 1 is equal to 2 sublevel, and gj is equal to 2 and mj is equal to plus minus half, so that gj is equal to 2 for mj is equal to plus minus 1. 3 square p 3 by 2 state is split up into 2j plus 1 is equal to 2, that is equal to 2 plus 3 by 2 plus 1, that is equal to 4 sublevel. So gj is equal to 1 plus g into j plus 1 plus s into s plus 1 minus l into l plus 1 upon 2j into j plus 1, that is equal to 1 plus 3 upon 2 multiplied by 5 upon 2 plus 1 upon 2 multiplied by 3 upon 2 minus 1 into 2 upon 2 multiplied by 3 upon 2 multiplied by 5 upon 2, that is equal to 4 upon 3. J is equal to half, mj is equal to plus 3 by 2 plus 1 upon 2 minus 1 upon 2 minus 3 by 2. So gj mj is equal to plus 2 plus 2 upon 3 minus 2 upon 3 minus 2. For delta mj is equal to 0, As per transition rules, only those transitions are possible for which delta mj is equal to 0 plus 1 or minus 1, with exception that mu j is equal to 0 to mu j is equal to 0 is not allowed. For mj is equal to 0, two transitions are possible. From mj is equal to plus minus half for 2p 3 by 2 to minus mj is equal to minus half for 2 s 3.2 gives two different frequencies, nu1 and nu2. That is, nu1 is equal to nu0 plus delta nu inside the bracket 2 upon 3 minus plus 1 bracket complete, that is equal to nu0 minus 1 upon 3 delta nu, and nu2 is equal to nu0 plus delta nu inside the bracket minus 2 upon 3 minus 1 inside the bracket complete, and that is equal to nu0 plus 1 upon 3 delta nu. For delta MA is equal to plus 1, again one transition is possible, that is from mj is equal to plus 3 by 2 and mj is equal to plus half for 2p 3 by 2 to mj plus minus half for 2s 3 by 2 gives two different frequencies. Nu3 is equal to nu0 plus delta nu inside the bracket plus 2 minus plus 1 bracket complete is equal to nu0 plus delta nu, and nu4 is equal to nu0 plus delta nu plus 2 upon 3 minus 1 bracket complete is equal to nu0 plus 5 upon 3 delta nu. For delta mj is equal to minus 1, again two transition is possible. For mj is equal to minus half and mj is equal to minus 3 upon 2 for 2p3 by 2 to mj is equal to plus half and mj is equal to minus half for 2s 3 upon 2 gives two different frequencies. Nu5u is equal to nu0 plus delta nu inside the bracket 2 upon 3 minus plus 1 bracket complete, that is equal to nu0 minus 5 upon 3 delta nu, and nu6 is equal to nu0 plus delta nu inside the bracket minus 2 minus 1 bracket complete, that is equal to nu0 minus delta nu. So the D2 line of frequency nu0 split into 6 lines of frequencies: nu0 plus 5 upon 3 delta nu, nu0 plus delta nu, nu0 plus 1 upon 3 delta nu, nu0 minus 1 upon 3 delta nu, nu0 minus delta nu, and nu0 minus 5 upon 3 delta nu, and therefore delta nu is equal to E upon 4 pi m into b. The spectral lines corresponding to delta mg is equal to 0 gives electric polarization or pi component parallel to b, where delta mg is equal to plus 1 gives a perpendicular component, sigma component. Thank you dear students for your patient listening. See you again in the next video. Till then, bye bye, take care.